Hi everyone, welcome to our video on evaluating after using related rates. So a rate is something per something, which means we can use a derivative notation to represent rates. A common rate is something per time. So as a variable, we can label that as d variable dt. So like dx dt or dy dt or dc dt or whatever letter dt. And we can often then evaluate the expression with other givens. So in these two examples, we're going to do our related rate, which means we're really just doing implicit differentiation. So find the derivative. So really step one is, let's go ahead and just mark it, is really implicit differentiation. And then after implicit differentiation, we'll start to plug things in. Okay, but let's set up our equation. So we need to use implicit differentiation on y squared equals 3x squared minus e to the 4x. All right, so if we're doing implicit differentiation, let's show it in blue. So implicit differentiation, we've got, and also, so implicit differentiation, let's add with respect to time. Okay, so that's a special case here where we're just going to do the derivative of every variable term and then make sure to attach d, whatever letter, dt. All right, so the derivative of y squared is 2y, but then again, make sure to attach dy dt after. And then we have equals. The derivative of 3x squared would be 6x, and then we'd want to attach dx dt after. And then minus the derivative of this, which would be 4 e to the 4x, and then again attach dx dt. Okay, so we're going to find the derivative. So when they mean whatever the derivative is that's left over after we plug these in. So we're going to use these now to plug those in. So step 2, let's label it in over here, plug in givens. Okay, so we're going to take this equation that we have right here and start to plug everything in. So I have 2 times y, which is, they're saying is 1. So we have 2 times 1. dy dt, they didn't tell us what it is, so we're going to leave that as dy dt. And then we have our equals 6. X, they said, is 0. So we'll plug 0 in. dx dt, they said, is 3. So we'll plug 3 in. And then we have minus 4 e to the 4 times x, which is still 0. And then dx dt, which they said is 3. Okay, so let me just show, well, actually, let's not do that because it, okay, so I just wanted to put it there, but I decided against it. I am subbing in 3 for the dx dt, and it looks just like this. And remember, the dx dt is its own variable, so you don't want to treat just the x by itself. You want to treat the whole dx dt as 3. Okay, so now we have this. And so it looks like the derivative they want us to find is the only one that's left over, dy dt. And then so let's start to continue, or let's continue simplifying. 2 times 1 is 2. And then we have dy dt equals 6 times 0 times 3 is 0. So we could skip that and we can keep going. And e to the 4 times 0 would be e to the 0. But remember, e to the 0 is 1. So this is really negative 4 times 1 times 3. So that would be 12. So negative 4 times 1 times 3 is negative 12. And then now we can finish it off. Divide by 2. Divide by 2. dy dt in this problem is negative 6. Okay, so that's the rate of change of y with respect to t. So whatever y might represent per whatever time represents is some negative 6. Okay, and we'll get to applications in another video right now, but the applications are very similar to this. We just have to deal with a word problem first. Okay, let's do one other here. Okay, so it's the same steps. Use implicit differentiation, and then we'll plug in the givens. So step 1, let me go ahead and write a equals pi r squared. Okay, so this is the area of a circle. Area equals pi r squared. And our step 1 is to do implicit differentiation. Okay, so I've got the derivative of a would be 1 So a is a variable, but again, with respect to time means dA dt. And then equal to our pi is just a constant, so pi would just be hanging out, times the derivative of r squared, which would be 2r, and again, attach dr dt, like that. Okay, so notice the letters don't really matter. We had a and r, but it's still whatever letter, d whatever letter, dt. And that looks good. And now at this point, step 2, we're going to plug in the givens. So that's those. And continue to simplify. Okay, so 1 times dA dt. They didn't tell us dA dt, so that means that looks like the one that we're trying to solve for, equals pi times 2 times r, which they're saying is 10. So we'll sub that in for that r. And then dr dt, they're saying is -2. Like that. Okay, so all of that's in. And this one's a little easier. It looks like it's just kind of different letters and symbols, but otherwise it looks like we're pretty much there. dA dt equals 2 times 10 times -2. That would all be -40. And then afterwards we'd probably attach the pi. Okay, so what this might represent, so this is the change of an area of a circle with respect to time. So whatever this number is, so like maybe it's a circle that was grass and the dirt's eating at it or something. I don't know. It's some weird scenario is what's happening. But this is the change in the area of a circle with respect to time is how we would probably be thinking of what this represents. Okay, so we'll put those applications to our next video, and for now we'll call it quits. Okay, so thanks for watching. If you have questions, let me know. Otherwise, I'll see you next time.